Today's lesson is called Understanding Addition of Integers. It's just an attempt to make what we're doing a little more clear and have an understanding of the process. And I think I'm going to need to turn the lights down a little bit so you guys can see this. That's a problem when you try to do something fancy. Does that help? Can you see that? No? I can turn them all off. Can you see it?
Yeah, we haven't had this already.
Is that okay? Can you still see it right now? Okay, do close your Chromebooks though. Those shouldn't be open right now. All right, so this is our list of standards. We're still doing the same standard where we are representing addition and subtraction on a vertical number line. Okay, this is not in your notes, so I want to talk about this in very general terms, finding the sum of P plus Q. So just all eyes up here for a second. If we're finding the sum of P plus Q,
but we're all ninth grade students with a name from Paige Monk to Ella McGargle, Pete Rose plus 10, and Emma Musser through Natalie Zimmerman load the other bus. Thank you.
okay, so if we're saying finding the sum of P plus Q, P and Q could stand for any numbers. They're just kind of any number plus any other number. So I asked the first question, what if Q is positive? So on this number line, I'm going to put point P, and I'm just going to pick any place to put point P. If Q is positive, where might Q go? Sky?
Towards the right of that.
Somewhere towards the right. We don't know what Q is, but I'm just going to put point Q there. Whatever Q is, how far away from P is Q? Jake?
Would it be the same number?
What do you mean by the same number?
Like would P be 7 and Q be 7?
Not necessarily. Q could be different from P, but if, let's go with that. If Q was 7, how far away from P would it be?
14.
No? Because if P was 7 and Q was also 7, we'd have 7 and 14, but how far apart would they be? They'd be 7 units apart. So for any number Q, Q is always going to be Q units away from P. What if Q was negative? Where would we put Q? Let's do that on this number line. So if we have P here, where would Q go if Q was negative? Zoe? It will go somewhere on the left. And if Q, if we're using the same number for Q, it would go the same distance away as in the first number line. Now I want to think about some other things. So I'm going to erase what I just wrote. What if P is negative? So let's put a 0 on our number line so we know where the negative numbers are. And let's put P somewhere over here in the negative zone. Now, what if we do P plus Q? Will the sum, P plus Q, be negative or will it be positive? Or could it be either? Irene?
It could be either, correct? Because if it's like, say Q is at 1, then P looks like it's a little bit more than one away, so it would be a negative number then. But if Q's, I'm just going to go some ridiculously big number, 100, then it would definitely be positive because P would not be able to balance out that 100. Because when you add them, it would be a positive number.
Okay, good. That was some good use of reasoning using actual numbers. Devin?
If they were both negative, it is not. I don't think it is possible, I think.
Okay, so if they were both negative, then you would definitely have a negative sum. It wouldn't be possible for them to be positive. Good. Any other ideas about how we could express that? Irene had some really good things. I hope the recording picked up what she had to say. She said that if Q was big enough, basically, so that it ended up over here. So if Q was bigger than P, then when we add Q on, say P was negative 3, if Q was positive 4, then we'd be okay because 4 is bigger than 3. So we'd get out of this negative zone and we'd get into the positive zone. So if Q is larger than P, we end up with a positive sum. But if Q is less than P, so let's put P over here. If Q is less than P, it doesn't necessarily have to be negative. Even if it was positive and it was less, we'd go so many units to the right, but we wouldn't get far enough, and Q would still be negative. Just wanted you to start thinking about this in terms of very abstract thinking using letters instead of numbers. Now we're going to move into the common numbers here.
Isn't letters instead of numbers, like, isn't that
Algebra?
usually algebra?
Yeah, that's algebra. We do a lot of kind of, they should really call it 7th grade math foundations of algebra because we do so much of it. Okay, counting up. Normally whenever we add, we're counting up, right? So let's look at 2 plus 4 equals 6. If we start at 0, we go up 2, we count up another 4, and we end at 6. Now, normally when we add, we're counting up. So this problem shows addition, which is counting up. However, when we add a negative number, we don't go up or we don't go to the right, we go to the left. So when we add a negative number, counting up becomes the same as counting down. So we go to 2, and then we go to the left 4 units. That has the incorrect sum. That should say negative 2. And we end up at negative 2. So make sure you make that change. I must have just copied that and not changed that.
Yours was wrong, was 3.
Oh, yours is right. Okay. Oh, that's right, because I didn't make these. Okay, now let's take a look at what happens if we do this on a vertical number line. You've already had some experience using vertical number lines. If we do 3 plus 5, we're counting up. So we're going up to 3, and then we're going up 5 more units for a sum of 8. But if we count up here, we're really counting down because we have that negative sign. So we go up to 3, and then we go down 5 units, and we end at negative 2. Kind of hard to see that. Okay, so the examples ask you, it says counting up negative 4 is the same as the opposite of counting up 4. So the opposite of counting up 4 is to count down 4, and also means counting down 4. For each example above, what is the distance between 2 and the sum? So let's go back to these examples. What is the distance between 2 and the sum for this problem? Sky?
4.
It's 4 units. So over here, let's say that the first example, it is 4 units. How about the second example? How far away is the sum from 2? Grace?
4.
It's also 4 units. Good. From here to here is 4 units. So in the second, it's also 4 units. Does the sum lie to the right or left of 2 on a horizontal number line? So look at the first example. Does the sum lie to the right or left of 2? Riley, which way does the sum lie?
The right.
To the right. How about in the second example? Let's do both of these while we have it there. Is it to the right or left of 2? Okay. So the first example, whoops, I went too far. First example, it lies to the right. And on a vertical number line, it would be up. In the second example, it lies to the left, which would be below on a vertical number line. Okay, now, letter C says, given the expression 54 plus 81, determine, without finding the sum, the distance between 54 and the sum. What is the distance between 54 and the sum? Katie?
81.
It's 81 units. Excellent. So since we're starting at 54, we're going 81 more units to the right. The distance is going to be 81 units. Okay, next one asks, is the sum, so the sum of the problem that they were just talking about, would it be to the right or left of 54 on the horizontal number line? Braden, which way would the sum be? It would be to the right. And then Braden, would that be above or below if the number line were vertical? Good. Okay, next one, given the expression 14 plus -3, determine without finding the sum, the distance between 14 and the sum. Ailey, what would be the distance between 14 and the sum? 3. It would be 3 units. Good. And then is that sum going to be to the right or left of 14 on the number line? Dakota?
To the left.
To the left. And would it be above or below if it were vertical?
Well, I know,
No.
1.
If it's a -3,
Oh,
we're going to go down. Okay, any questions about this? Okay, exercise 2 asks you to work with a partner to create a horizontal number line model to represent each of the following expressions. So there's only a few there, so I want you to take about 2 minutes and do those. You can work independently or you can discuss with a partner. All right, Katie, come on up and do the first one. And then we'll do Zoe and then Elena.
-5, so I went 2 to 5. And then it's +3, so I added. And I got -2.
All right, thank you very much. Any questions about this one? Come on up, Zoe. So letter B. Okay, Zoe, what told you to go left? Why did you decide to go left?
Because
Ailey, why did she go left? Because it's still negative. So negative signs tell us that we need to go to the left. Come on up, Elena. You can explain what you're doing as you're doing it. That would be great.
so +7. And then plus
Okay, and why did you decide to go to the left?
because -8 is negative.
Okay. Okay. Isn't this kind of nice and refreshing after how hard the last unit got? This will get harder, but it's nice to have an easier start. Okay, exercise 3. Write an equation and using the number line, create an arrow diagram given the following information. The sum of 6 and a number is 15 units to the left of 6 on the number line. All right, if you haven't already thought about this, I want you to take 30 seconds or so just to think about what that equation might be. You can write it down if you want to.
Do I have to answer this one?
Yes, but give me just a moment. Okay, Irene, do you want to give it a whirl?
Yep. Should I come up?
Yeah, you can come up.
So I started, should I draw it on the number line or?
Sure,
do
yeah,
the
you can
equation?
draw it. Sometimes
Okay.
it's easier to start
Yeah.
that way.
I drew a line over to 6.
Make sure your arrow starts at 0.
Oh, yeah.
Hard to see sometimes when you're out there. Okay, good.
Okay, and then I went back 15 all the way over to -9. I think Mercury kind of cut off a 9. But then for my equation, I did 6 plus -15 equals -9.
Yeah, very nice. And I think the way Irene did it was really good, to start with the number line, because then you can just kind of follow the directions. You know you're going to start at 6, and you know that the number is going to be 15 units to the left of 6, so by doing that first, that helped her realize that she's going to be adding negative 15. Okay, one more thing. This is not in your notes, but I have a question to pose to you. If I have the problem 2 plus negative 16, what does the absolute value of 16, of negative 16, tell us about that problem? Jake?
You're subtracting 16 units. Like you're going to the last 16.
But what does
Or
the
you're
absolute
adding.
value of 16 tell me? So the negative part does tell you that you're going to the left. Eve?
It means that your sum is going to be 16 units to the left of 4.
Okay, yeah, your sum will be 16 units to the left, but why do we care so much about the absolute value? Irene?
Because it shows you how many units to go over.
Okay, the absolute value gives us the length of the arrow or the distance. So you all kind of were heading toward that. It tells us that this number, negative 16, is 16 units away from 2. And yes, it happens to be to the left. If it were positive, it would be to the right. But the absolute value gives us the distance between the first number and the sum. Okay, any questions? All right, let's see. We have a little bit of time. We're going to spend some time playing the integer game, and then you will have an exit ticket to do. So we probably will start the exit ticket first thing after the bell in the lab class. And then your homework is going to be problem set 3. There are 5 questions, and you will do all of them for homework. So go ahead and play the integer game for about 10 minutes or so.